Hi, my name is Rogério da Silva, and I'll be showing you how to pass on the ISTQB exam, and this is section 3. So in this section, we're talking about the static testing. We'll be covering all the elements of static testing. Okay, so hang in there and watch the videos. Let's get it started. So what we will learn on this third section? We're going to talk about static testing techniques, the importance of reviews, typical types of defects found in reviews, carried out a basic and formal review, roles and types of reviews. So we're going to talk about the differences between them, which is informal, walkthrough, technical, and inspection reviews. What are the success factors of reviews? What is static analysis? The benefits of reviews? Use of static analysis tools. Let's go. Static testing techniques. So as you can see in this graphic here, there's a difference between uh, what's necessary to carry out a static testing and what's necessary to carry out a dynamic testing. So our primary focus now is to talk about static testing. It's divided between reviews, walkthroughs, and inspections. In the later point, we're going to talk about dynamic testing, which is probably going to hear more about functional and functional unit test, integration system testing, and performance tests. So our focus now is reviews, walkthrough, and inspection. So static testing is the examination of a program source code or other documentation without the execution of the code to find defects. So the two types of static testings are reviews and static analysis. So reviews is done by humans, the manual examination of the documents. Static analysis is done by tools, is the automated analysis of source code and software modules. So as opposed to dynamic testing, which is performed by executing the software on the test and comparing the actual and the expected results. So reviews and static analysis have the same objective as dynamic testing in find defects. Static testing is a complementary technique. It finds causes of failures, defects directly, while dynamic testing finds failures which may cause defects. Okay, reviews. So as you can see in this graph representation, which looks like a spaghetti, I'll try to use as much as images as I can, as I believe it can help you memorize and think about. So this, it's a roughly idea of everything involved in the development process of the software. So pretty much anything can be reviewed in order to improve and find defects and improve the software. So a typical written project document or software product that can be reviewed are business requirements, functional specifications, system and database designs, source code can be reviewed as well, test plans, test cases, scripts, end user guide or help text that been used to support the development and the actual user itself, web pages. So as you can see, pretty much anything can be reviewed. Continuing on reviews, the benefits of reviewing as early as possible is simple, easier and cheaper to fix, period. So early defect detection and correction, increase development productivity, reduce development cost and timescales, fewer defects in code, reduced time and cost of dynamic testing, improve communication between testers, analysts, developers, and users. So as you can see on this graphic here, uh, why the defects are more likely to be introduced. So requirements is just a little bit. Coding, that's where it's more likely to happen. The integration be less, testing section, like in UAT, and the support when the products have already been gone. So as early as you start, and requirements and coding is better. Types of defects found in reviews. So the aim of reviews is to check and improve the quality of project products, such as verification, validation of documents against the specifications and standards, consistency with predecessors, documents, and completeness and conformance to standards. So basically is error, which is related to human, so human make errors, omissions, additions, inconsistencies, ambiguities, readability, terminology, spelling, grammar, layout, and structure. So those are the key things that you look at when you're doing a review. Now that you have an idea what you're looking for in a review, so this is the basic review process. A good review will also include casual analysis to learn from issues and bring out process improvement. By involving a number of reviews in a controlled manner, consensus can be reached on subjects such as a best design practice. So in this chart here, it shows that a document under review is studied. Then reviewers identify issues and inform the author. And then the author decides on actions to take and update as needed. So reviews are better than dynamic testing at finding some types of defects, such as checking standards, identifying inconsistencies in requirements and designs, assessing maintainability, and checking interface specifications. Now, as part of the review, the formal review process, the way review works depends on the agreed objectives. The intention is to find defects, gain understanding, educate testers and the new team members, or discussions and decisions by consensus. So here's a typical formal review activity. So first is a planning, then a kickoff, then individual preparation, review meeting, rework, follow up. This will fall on the exam, believe me, trust me. So planning, moderator define the criteria and what to review, allocate roles, define entry and exit criteria. Kickoff, document distributed to reviews 1 to 3 days in advance. Objectives, process and documents explained to participants. Individual preparation, reviewers read and note any potential defects, questions and comments. Compare product to predecessors, products, standards, guidelines, and best practices. Review meeting. Participants discuss the document, note defects, and log findings. Moderators ensure discussion is kept on track and remaining objective. Some reviews only defects is discussion, other may discuss alternative solutions. Real work. Following the meeting, the author corrects the document based on the defects found and update the status defects. And finally, the follow-up. Moderators ensures document is now corrected and collected metrics such as time spent reviewing, defect density, and breakdown defects by business area or severity. So this information will be used to find recurring issues. In this topic, review roles. So what are the roles of individuals working on the review process? So manager, moderator, author, reviewers, scribe. So what do they do? So manager decide what to review, allocate time in the terms of whether objectives have been met. Then the moderator or leader manage the team, include planning, motivating, facilitate meetings, training reviewers and monitoring the process. Also record summary results for the follow-up action. And then the author prepares the material to be reviewed, participates in discussions during the review meetings, and incorporate the agreed changes afterwards. And the reviewers, as known as checkers or inspectors, is responsible for finding defects. So stakeholders should have technical or business background, ideally from different areas and focus, such as business users, developers, analysts, IT operators, testers, and compliance officers. And the scribe or recorder documents all the issues, problems, and open points that were identified during the meeting. So in this graph, a representation of the 4 types of reviews. So on top of the graph, informal, then after that, walkthrough, then technical review, then inspection. So this indicates the level of formality. So informal has low formality, and as you get towards the inspection, then you have a much more higher formality. So bear this in mind, the 4 types of review: informal, walkthrough, technical review, and inspection. Continuing with the 4 types of review in more detail, so the informal means one-to-one discussion with no formal process. For example, body reviews, pair programming, design review, or code by a technical team leader. So walkthrough, led by the author, taking you through the scenarios, dry runs, and peer group, useful and highly visual via storyboarding or workflows, etc. Seen as a more passive approach, presenting the information, finding defects, but not proposing solution. Opportunity for testers analyze and query the document. So technical review, it's a defined defect detection process involving both peer and technical experts, led by moderator and vary from informal to very formal. The goal is to review from technical and specialist viewpoint, to discuss, make decision, evaluate alternatives, find defects, solve technical problems, and check conformity to specification plans, regulations, and standards. And finally, the inspection. It's a very thorough formal process design to find defects in documents and program source code using rules, checklists, and entry and exit criteria. Inspection is led by a trained moderator. Also involve casual analysis, look at common causes of defects, and provides feedback to improve future development and inspection processes. Okay, to represent informal review, uh, made up this chart. So the main purpose is to find defects and uses no formal process. So he is the author. So the author creates a new review, identify what's need to be reviewed, and then the item is ready for reviews, and it pass on to the reviewer. So that one of the reviewers can be a tester. So the reviewer examines review items and log anomalies, log time spent in the review, and then progress the notification, and then the author examine and fix reject anomalies and pass on again to reviewer. The reviewer complete again, and then the author examine and fix reject anomaly, and then mark the review is complete. So a walkthrough are very useful for highly visual products via storyboard, workflows, tools, etc. So a walkthrough should find defects, but not propose solutions. So this is the author's task after the meeting. So this graphic is just represents one of the visual walkthrough you would see out there when you actively working as a tester. Technical review, a bit more in depth. Enable decision making, finding defects, solving technical problems, and checking conformity of documents. So this a specialist viewpoint is to discuss, make decisions, evaluate alternatives, find defects, solve technical problems. So check conformity to specification, plans, regulations, and standards. So the technical specialist should be someone like a technical architect, data design, compliance officer, a system administrator. Again, really quick about the inspection. So the main purpose is to find defects and process improvement. The inspection process is a very thorough, formal process designed to detect defects in documents and program source code using rules, checklists, and entry exit criteria. Here's a graphic to represent these so you have an idea. So it's planning, overview, individual preparation, inspection meeting, rework, and then if it needs to go back again, individual preparation, inspection, meeting, rework, and then follow up, and then you do an analysis of inspection, and then you complete. So what are the success factors for reviews? So for any type of review to be successful, it must have clear, predefined objectives and must involve the right people for the review objectives. These include testers who are valued reviewers and can contribute to the review and also learn about the product, which enables them to prepare tests early. So each review should have predefined and agreed objective. Any defects should be welcomed, conducted in an atmosphere of trust. Techniques are suitable to work product type, emphasis on learning and management support. So those are the success key points for any review process you engaged on. Static analysis, so used to find defects in software source code and software models. So the objective of static analysis is to find defects in software source code and software models, but not written documents. It requires the use of tools and is performed without actually executing the software being examined by the tool. So static analysis finds defects rather than failures. So static analysis does not test functionality, but can locate structural defects that are hard to find in dynamic testing. So here's an example. So a looping code. So if you had this looping code working on a system, you would not flag as a failure or a defect because it will continually work as is being written. But if you do a static analysis on it, then you will identify this loop and then you can prevent it to happen before the code is actually executed. Here's an example of benefits of static analysis. So early detection of issues prior to test the execution, early warnings about suspicious code or design, identification of defects not easily found by dynamic testing, so improved maintainability, and is a prevention of defects. So in this example, the statement cannot drive will never be executed as the condition is if over 18 will always be true. So it's an unreachable code. In static analysis, it will be much more easy to identify these other than dynamic. Continuing on the benefits of static analysis, here's another example of the typical problems a data flow analyzer would detect. So you see A, B, E, and F is defined, but like F is not used, and X, see, X is not defined. So this is the kind of things that testers should be looking at. So there's some definitions in there on this code, but there's some others that is used on the code, but it has not been defined according to this example. So use of static analysis tools. So static analysis tools are typically used by developers to check against the predefined rules of programming standards. So before, during component unit and integration testing. Many of these tools provide graphical representation of the code, and this can be useful for testers to help pinpoint where a complex source code which might indicate possible defect clustering, helping you focus for the dynamic testing. So you can, this is a graphical representation of a static analysis tool. So the coders, they code the program, and you can kind of have a preview of the program, and then some programs pinpoint where there's some critical or heavy code that you can expand and look it into a section. Like for example here, if this was a code, a graphic code, so you could just like highlight these number 4, and then you will be able to see the codes on these, and some of the tools can actually indicate if it's something critical on this code, and it can help you focus on that specific area and specific feature. Now reviewing what you learned on this section, so it comes to an end, the section 3. Well done. So this is what you learned so far. So the two main static techniques, we talked about that. We talked about reviews. We talked about types of defects found in reviews. So basic review process, formal review process, review roles, 4 types of reviews. We talked about informal review in more depth. We talked about walkthrough review, technical review, inspection, the success factors for reviews, then the static analysis and its benefits, and finally at the end we used how we can use the static analysis tool on you a benefit as a tester. Okay, well done. So you made the halfway mark. So you complete the first, the second, the third section. So now you complete the static testing. So make sure you go down below and get the attachment, the quiz. Practice with the quiz so it helps you memorize the section. Focus on that. Especially now that you just complete, because the memory is fresh and everything. So well done. So now 3 more to go. Don't forget to make any questions down below on the designated area. Make any comments as well, any criticisms that help me again improve this section or improve my my skills on show you the material. There's gonna be so much more material after this ISTQB, I promise you. And if you really like it, thumbs up, and say I like it, and I want to share with my friends, share with all the other guys that benefit from it as much as I did, and because you're gonna pass. I know you're gonna pass. It's gonna be so easy for you to pass, honestly. Okay, so move on. Bye.